Relations and functions. A function has a domain, which is also known as your input or independent variable, and a range, which is your output or dependent variable. Also, a function has to have exactly one output for every input. If these two criteria are not met, it is not a function. So again, has to have a domain and a range, and every input has one output and only one. So the first diagram illustrates what not a function would look like. As you can see, the input of 1342 has an output of 104 and 111. So again, every input has to have only one output. The bottom diagram, as you can see, every input only goes to one output. So therefore, it does represent a function. I want you to answer if this is a function or not. If you're given a graph, we're going to use what we call the vertical line test to determine if something is a function. If, in order to be a function, a vertical line is only allowed to pass at one point on the function. So that's why the diagram or the graph on the left is a good function, because every vertical line, and I can draw several, and it's supposed to be straight up and down, only touches the blue graph one time. So that is good. But the graph on the right, this one line hits two spots. So again, the vertical line is only allowed to touch once. Functions can be continuous or discrete. Continuous just means pretty much together or connected. Discrete means separate or broken. So again, continuous is connected. So it's continuous, connected. Discrete is broken or separate. So for example 2, I need you to tell me, is it continuous or discrete? So the number of cars in a parking lot and the amount of people each holds. So cars is going to be a definite number, as well as people. So since both numbers are definite, meaning there's no half, you can't have half of a car or half of a person, so there's only definite wholes, this would represent a discrete situation. However, the length of hair, when you're dealing with measurement, you're dealing with some fractions and decimals, so there are more than just whole numbers involved. So in that situation, it's continuous. So essentially, discrete only involves whole numbers. Continuous can involve whole numbers and fractions. All right, let's recall the difference between domain and range. Domain is the list of all the x values. So you would ask yourself, how far left does the graph go? Or how far right does the graph go? The range of a relation is the list of the y values. So you would ask yourself, how low, or what's the lowest point of the graph? Or how high is the graph? If the relation or function is discrete, you would have to write out every single x or y value if asked to write the domain or the range. If the relation is continuous, you need to be introduced to other methods of writing it, because it's impossible to write down everything. So you're going to be introduced to what we call interval, inequality, and set notation. So we're going to use the example of y equals x. Y equals x, if I were to graph it, it's a straight line, okay? And runs, since it's a line, that means it goes on in both directions forever. So the domain of a line and the range is, in words, any real number. In symbols, you see this fancy R? That represents any real number. But you can also write the domain and range using the three methods I told you before: interval, inequality, and set. In interval notation, the domain would look like a parentheses, a negative infinity symbol. So think of the infinity as an 8 taking a nap. Then you would do comma, the positive infinity symbol. Remember, you're only listing the x values. So the smallest x value goes on the left, and the highest x value goes on the right. And then for the range, it will look exactly the same, but again, it's only dealing with y. When you're using interval notation, sometimes you would use brackets if you have a definite stopping or starting point. So that might also be possible. And if you don't have a definite endpoint, then you would use parentheses. Again, I'll demonstrate in just a second. For inequality notation, use the same symbols as interval notation, but you also use the less than symbol most of the time. Other times you can use greater than in certain situations, and I will talk about those when we get to them. But for this particular case, it would say negative infinity less than x less than infinity if I'm referring to domain. The range would be negative infinity less than y less than infinity. And then set notation is pretty much just a fancier version of inequality notation. You use these little swirly braces. Then you tell me the variable. So for domain, it's x. Then you provide this bar that represents such that. Some other textbooks will use a colon instead of a bar, which is fine. They have the same meaning. And then what you put after the bar or the colon is basically inequality notation, or you can put words. So I decided to use the inequality format. So negative infinity less than x less than infinity. So let's answer this question together. This is a discrete function because, again, it's broken or not connected. So if I were to take all the ordered pairs and put it in its table form, this would be the table. All right. So you can see all the x values with their corresponding y. So at negative 5, the y value is 3, and so on and so forth. So is this a function? To determine if it's a function, we're going to use this vertical line here. And it doesn't want to move because I still have my eraser on. I'm sorry. All right. So vertical line. Does the vertical line touch more than one dot? Right there it does. So is it a function? No, it isn't. It is not a function. It is a relation, but it's not a function. Then what's the domain? So the domain, again, you list all the x values. So we have our swirly brace, and we just list all the x's in order from least to greatest. So negative 5, negative 3. Notice that 1 repeats. We only need to write it one time. And then 4. The range, again, we list them all out. So we have 3. Oh, put it in order. Put it in order. So So we would have -3, 1, 2, 3, and then 6. Always from least to greatest. So when it's discrete, again, you list them all out, but you put them in a fancy brace as well. For number 4, we have a continuous or connected graph. So the first question is it a function? So let's get our line and move it to determine that. So here's where the function starts. Notice the line only touches it at the endpoint. Again, as I move it from left to right, the blue line representing the vertical line only touches the function one time. So, yeah, or the relation one time. So yes, this relation is a function. So now we got to state the domain. Since it's continuous, again, you have to use either interval, set, or inequality. Let's start with the domain, and domain is your axis, right? So if I had a highlighter, I would highlight the areas, but I'm going to use a different color pen to demonstrate this because my highlighters are not cooperating. So how far left does the graph go? So if I go to the leftmost spot is -5, and there's an endpoint. So draw a wall and label it -5. Then trace to the far right of your graph. And as I go to the far right, notice there's an arrow. When there's an arrow, you can't build a wall. So you would put infinity on the far right. If the arrow's on the far left, it's -infinity. So we would say in interval notation that the domain has a bracket because that's an endpoint at -5, and then comma infinity and use a parentheses. Again, you have to use a square bracket on the -5 because that's a definite point. Now, in inequality notation, come on, pen. Come on. All right. In inequality notation, you would say -5 is less than or equal to, because it's definite, so you got to put your equal bar, x less than infinity. Don't put the equal bar with infinities. Only equal bars on definite points. And then you could go ahead and try set builder on your own. Remember, it's just a fancy way of saying inequality. Now for the range. You go to the very bottom of the graph. The very bottom has an arrow. So we can't draw a line, but we got to recognize that the lowest little b is infinite, but we're at the bottom, so that means it's -infinity. And then when I go to the tip top, the highest it goes looks to be 9. So write 9. So if I'm writing interval notation, I would say parentheses, because again, you start from the bottom, so -infinity, comma, +9, square bracket, because that's a definite stopping point. For inequality, you would say -infinity is less than y, since we're dealing with range, is less than or equal to 9. And again, I want you to try set on your own. Usually, I'll tell you what notation to write. If I don't tell you what notation to use, the choice is yours. So this concludes our notes for this lesson.